Hi, this is Mr. Mitchell. I'm one of the physical science teachers at Coosa High School, and we have a video here about literal equations. Literal equations is one of the math components of the high school physical science class. You know that physical science has all kinds of formulas, and this is one of those formulas. F, force, equals m times a, mass times acceleration. And many times you want these formulas to have some simple math to it, where you're given the mass and you're given the acceleration, and all you do is just multiply them and you get what's over here. But that's not always going to be the case. And I have an example of a question up here where it does that. Lisa used 10 newtons of force when she hit the nail with a 4-kilogram hammer. What was the acceleration of the hammer whenever it hit the nail? So it's not asking for force, it's asking for acceleration. So literally equations is taking existing formulas and moving things around to find the value that you need. In this case, the value that you need is acceleration. So how can we find acceleration when acceleration is on the other side of the equal sign? So we fortunately have some rules. Look at the rules down here. We have rule number 1, isolate the value you are finding. So why don't we just do that? We want to have a by itself on this side of the equal sign. So here is one way you can do that. M is multiplied times a in the regular formula. But we want to get rid of this m. Now we can't just completely get rid of it because it's part of the formula, but we can get it on the other side. Anytime you have things that are multiplied together, you can isolate a value by dividing by everything else. So in this case, we're trying to isolate a, and we just need to get rid of the m and put it over here. And you do that by dividing anything that is multiplied to that value. So in this case, we're dividing this side by m. But look at the rules. What you do to one side, you must also do to the other. So since on this side we divided by m, we're going to have to go on this side and do the same exact thing and divide by m. So what happens is this m cancels out with this m, and you're left with F over m equals a. Now, so you can get kind of a conceptualization of this, if this m took the place of, say, the number 5, you could get rid of the number 5 or move it around by dividing by 5, because 5 divided by 5 equals 1, and 1 times a is just a. So it works out that anytime you have multiplication on one side, you can isolate what you need by dividing by everything else. Now notice it says equations can be flipped. What you have now is F over m equals a. I want to flip that because it just seems to work best when you have the value you want on the left side and then what you plug in on the right side. So this literal equation has given you what you need for a, and you could then plug things in. What if you were solving for m? What if m was the value you were finding? Let's have the original formula here. How would you take this a away from this side? Since you're multiplying m times a, you would divide by a. Anything that you're multiplying by, you can divide by it to move it to another side. Remember, number 2, what you do to one side, you must do to the other. So we are going to also divide by a on the other side. That cancels out with that, and you are left with m, and I'm going to flip them just because we can, and I like having the unknown value on the left side. M equals F over a. So does that make sense? Whenever you have something like a multiplication on one side, that's how you would do it. I'm going to clear this and let's try a different one. Why don't we go with this formula? Here is the formula for speed. Now you may remember this also can be velocity equals distance over time. It's the same thing. So let's try to isolate d. let's try to isolate distance. So in this case, distance is, well, it's not being multiplied by anything like the other one was. This case, it's being divided by something. So the rules are a little bit different, but I bet you can even figure out what it is. So whenever you are dividing by something to move this t to the other side, you then multiply. So I'm going to multiply both sides by t. You know, whenever I was dividing, I had to divide. Whenever we had the previous formula, I had to divide to get rid of it. Now I have to multiply to get rid of it because it's something over something else. So what I do to one side, I must do to the other. So I'm going to multiply the t to this side also. Remember, the little dots mean that you're multiplying. So the t cancels out with the t, and you are left with d equals t times s. Now I like to put things in alphabetical order, and I'm going to flip them because equations can be flipped. So d equals t times s is the same thing as d equals s times t. Okay, what if I am solving for t? Now that's a pretty tough one there, but I'll show you how I know how to do it. I want to isolate the value I'm finding, and I want to isolate t. Now I just got through isolating t over getting t over on this side, so why don't I do the same thing? Because I know what to do whenever t is next to s here. So if I were to move t to the other side, it would be the same exact process we had before. Get the t's out from this side, and then I'm left with t times s equals d. So then I have t in a situation where I can work with it. So now I have to get rid of this s. And how would I get rid of this s? I would divide by s. So since I divide by s on one side, I have to do it to the other. These will cancel out, and t equals d over s. So that's how you would do linear, literal equations whenever you have the divisible sign right there. So let's try one more. Now this particular formula here is not one we have in physical science, but I just picked it out so I can show you what to do when you have a plus or a minus. Y equals mx plus b is a math formula that is not used in physical science, but why don't we solve for, say, x? So if we're solving for x, we're isolating the value we're finding. So we want x on the side by itself. Let's get rid of the plus b first. Here's how you get rid of something that is added to it. All you have to do to get rid of it and put it on the other side is subtract that value, because plus b minus b is b minus b, and that means there's nothing left. But remember, what you do to one side, you have to do to the other. So I'm going to subtract b over on this side as well. So that cancels the b's because b minus b is nothing. And we are left with y minus b equals m times x. So I'm not done yet. I'm still trying to solve for x. So I've got to isolate x on one side. So how would I get rid of the m? You would divide it. And since you divide on one side, you have to divide on the other. The entire thing. So m's will cancel out, and you are left with x equals, and I can flip it because equations can be flipped. X equals, let's see, what does that say over there? Y minus b over m. So I just flipped that equation. So you've seen what to do when you multiply things together. You've seen what to do in the previous slide when you divide things. And now you see what happens whenever you have a plus. You just minus it, and it gets it rid of that side. So I have down at the very bottom a practice sheet that's tinyurl.com/. Y5NKKSE3. That is on a sheet that you may have already received. If not, just type in that, and that will give you some practice for literal equations. Now, everything on that sheet is not used in the physical science curriculum. A lot of it is math, but it's just practice. It's just practice so you can practice and be familiar with how to isolate things on one side, to do to one side what you do to the other, and flip the equation so you can have equations you can work with. Well, I hope this was helpful to you, and thank you.